You see, this is Sabine Hassenfelder. I've been trying to get a hold of her for years and never had one single response whatsoever. She's talking about the Webb telescope. Just observe faster than light signals. Wow, this is amazing. Well, faster than light, we've been doing that for 10 years. So I said we did that at Mudfossil University 10 years ago. It's quite simple. Only requires a cell phone pulsed laser. And there's the actual light, and there it is accelerating. I mean, it's quite obvious. And I said we used light and found the muons and electron neutrinos, exact same particles as CERN and Fermilab. There they are. I showed them quite clearly. Now, Don Lincoln of Fermilab put this up 12 years ago. And then I said I also took a course at the University of Geneva, explained the CMOS would not be damaged by photons, but they use protons, which are 1,000 times bigger. And they destroyed the CMOS, so they couldn't use it. And that's what they told me, it won't hold up. And I said, they said because of the high energy. I said, no, it's because of the high mass. The energy is energy. It has no mass to it. It won't break it. It'll just see it as extremely brilliant. So we use the CMOS to photo the light particles, and CERN is upgrading right now to CMOS. And they're hardening it. They're making radiation hardened CMOS sensors so they can see the same thing we saw right here. Right here. Now, I would love to hear from Sabine, but she just never responds. I don't know. I'm going to actually put something here. I'm going to say, I would love to talk at Sabine. I've done that many times, so it's never worked before. Let's just see. Anyway, this just popped up just a few minutes ago. When she put this up, I don't know, 2 hours ago. I was just getting ready to put my other video up onto YouTube, and this shows up. Oh, what a world. Faster than light. Big deal. Okay, my outstanding friends, it just never ends. They've been talking really a lot about dark matter, and I've been posting really a lot about dark matter and really showing dark matter. But the new theories are coming out with this is a new theory about, is dark matter evolving? What is that supposed to mean? Dark matter is a substance. And it is a uniform substance. Every piece of dark matter is exactly the same size and has exactly the same characteristics. It has weight. And I will show you these particles because we could see them using CMOS. All right, let's start with this. I say this is wrong. They say the evidence clearly supports an expanding universe. Well, show me how it clearly shows that. I don't think that's correct at all. They say it has to be expanding because light is being pulled away. No, light is slowing down. That's all it is. We're getting slower light here, they say, because light never changes speed. It obviously does. I've shown it does. And they're saying, therefore, it must be being dragged away, so the universe is expanding. That's just not the case. All right, I'm going to make this extremely simple. We're going to cut right to the chase. Dark matter versus dark energy. Well, what's the differences and what's the similarities? Key differences. These are the different features: the gravitational effect, primary role, composition, and distribution of dark matter versus dark energy. Well, gravitational effect. Here's the story with the gravitational effect. Attractive as a piece of matter. If it's just a matter, the dark matter itself pulls all these little glowy particles around it. All right, now, when it's moving, it's energy. So when it's moving, it's repulsive. It pushes, they say, pushes through what it's going through. I can't dispute that. The primary role of dark matter is to form structures like galaxies. So they're saying it creates matter, it creates mass, drives the accelerated expansion of the universe. I don't necessarily agree with that at all. They say it's that the universe is expanding because light never slows down, so it has to be being stretched, because by the time it hits us, it has slowed down. It does slow down. That's it. It's very simple. Composition. What is it made of? Mysterious stuff. Dark matter is a little black ball. I'm going to show you. It's not mysterious. It's just, it's there. Dark energy, a mysterious force or property of space, which I can show you that too. Now, I'll show you this. I can show you all of the things I'm talking about. The distribution. I'll show you this. Dark matter clumps and forms a cosmic web in space. Dark energy fills all of space uniformly. That I don't agree with either. But it does cause a web, and I'll show you the web right now. All right, there's the web right there. This is space. I mean, if you don't see a web and all these little dark areas and then the white next to them, these are dipoles. Every time you see dark and then white next to it, it's a dipole configuration. They're not exactly one for one, so which adds a whole new dimension to it, because in the atomic realm, the subatomic realm, they are one black ball and one white ball. When you get into space, you've got globs of black, and then you've got globs of white next to each other. But you're not going to have a glob of black here and then no white in there. You see, you got black here, and then you got white over here, you got black here, you got white over here. They balance each other out, but in space, they're swishy. They're just in areas. Like, see the black and the white here? They're not exactly one to one. The other ones are. The ones here on Earth are. They're one to one, the black and the white. They don't understand this at CERN or Fermilab or any of them, because when they hit things together, they're hitting gigantic globs of things, and they get just a splash of stuff. We started with light using CMOS to detect it, so we can see it, and it does exactly what they say it does. These particles, it has all the weight, and is never changes size. One size fits all, and it has a glowy edge around it. The glowy edge is because the white, the bright part of the particle is shining from behind it. That's the only way you can see the black, is if it obstructs the white. And I can show you that right down here. They're normally glued together, these two. Called a Dirac neutrino, but it's nothing more than a dipole electron. Two dipole electrons back to back make up a photon. All right, looking at those photos from space, how the globular nature of the black and the glowy parts, it requires a lot more study to see how they interact. They're all interacting with fields. Now don't forget, I'm saying that's the black particles, and these are the white particles on here on Earth, in protons and matter and so forth. Now, I work with just one black and one white, well, 2 and 2. Each one of these is a magnet. It has a positive and a negative. Back to back, they're like two bar magnets. And that creates a photon. In this little article here, it's called Dipole Electron Flood Theory. It's a 5-minute read if you read very slowly. The white electron is the glowy part, and that gets big, it gets small, and this is the black dark matter part, which is the muon. It never gets bigger, it never gets smaller. It's always exactly the same size for blue, green, red, doesn't matter what color light. And I will show you that. And that has all the mass. And the only way you can ever see this is if it's on top of light that's coming around it. And you can see that it obscures that light. It's exactly what they say, and I'm show it to you again, again, and again. Those are the two particles. They can be separated, which we did. Normally they're gluons together. That's the tight nuclear force, because these are nuclear particles. These are the tiniest particles within a proton. It takes 1,839 of those particles to make one proton, just like this. 1,839. Now we started by using light, so we never got bigger than this. With CERN and all of them, they started with these. When they crash these things together, they just get piles of debris. We didn't have to do that. We could see these, and we can see them separate, we see them come back together. Now don't forget, when they see these black particles at CERN and Fermilab, this is right from Fermilab, this is right from one of their articles. The black is surrounded by a glowy, it's always going to be obscuring the light that would normally hit us. That's the only way you can see these. Just like here, you see the black right there? It's got the glowy edge around. The only way you can see it is because it's obscuring the light that would be behind there. Same thing with this one. Here they are here. They're obscuring the light that would be like this light here by being in front of it. And I can show it in more detail down here, right at the Venturi. This is the photons coming through the air a zillion miles an hour. And here it is accelerating. That's acceleration. Normally it had a nice wave like this sort of going through the air. And it's now, it senses the Venturi and pew! That's the particle itself, which was this particle right here. And at the Venturi, these black ones never can get small enough to get through the Venturi, so the white squirts through. See, they can be small, they can be big. They're just a field, and they have no weight to speak of whatsoever. This is electricity. This is electricity. It has no weight. And electricity is, if you took a 1,000-pound battery, 1,000 pounds, for a car, and you drained every little bit of electricity out of it, and it weighs 1,000 pounds, exactly 1,000 pounds, and then you filled it up with electricity, it's going to weigh 1,000 pounds plus 4 thousandths of a gram. There is no weight to this whatsoever. I mean, really none. The 4 thousandths of a gram compared to a 1,000-pound battery. That's how much. You run it all day long, go 500 miles, use every little bit of it, and it still weighs the same amount. Electricity has virtually no weight whatsoever. None. Zero. All your weight is in the black. And the black has dark energy, yes, it can push, and I can show that too. Now here's, I can show you even better detail than this. The black being on top of the white. Because here it's in phases. You see this? We're at the Venturi right here. Bam! And right there the white squirts through the very tiny little Venturi. It's just a little slot that comes through here. An angled slot, and all the fields have to crush together. And the white can do that. It can crush. The black can't, so the black stays back. Now here we are at the Venturi. Right there, there's little balls. Those are those little bitty balls. And the only way you can see them is they're on top of the glowy part. They're everywhere. You see up here in that red area right in here? They're in there. You just can't see them. Once you get down to the white, they obstruct the white. And here, they start to jump back in and attach back to the white. Every one of those is the same size. You can't really see that when you look at it. Some of them look small, some of them look big, but they're not. They're just obstructing in different amounts. When they're perfectly on top, you see a perfectly nice round ball, but that's the size of them, and one size fits all. Every color has the same size photons. They just doing different speeds, and I can show you that too. I'm not making any statements I can't stand behind, and we use CMOS to do this. Now this was from Fermilab in 2013. We did this, I think it was 2014. The phone and all that stuff was from 2012. It was a Galaxy S3, and a little laser, construction laser. And all this started then, and we saw the same particles, and we just kept going from there. Now I can show the black pushing the white. Here I'm showing only the white accelerating. That's just pure white. All right, but it does come back to the black. So the black's just laying around out here. This is what I was thinking. Where did black come from? It doesn't jump from here over to there. So the black has to just be laying around, sucking the white back into it. Because this, you know, this is light. This is not a very big distance. And that's the particle right there. And here's where it explodes because of the backwards EMF, the electromotive force backwards, causes that. And then you get this big field effect back there in the back. You see it? That's reverse. It's not supposed to be going that way. And I know they're watching what I'm doing here with this because I send it to everybody. And then I'm seeing everybody's talking about dark matter, and we can go backwards in time now because we can see the particles going backwards. It's just bouncing. It's just bouncing. It's not going back in time. They have all these, I'm seeing articles, I just can't believe what they're saying. They're trying to come up with something. And then I saw another one about how space might have memory cells. They're thinking there's probably some cells out there that are actually memories. What does that mean, and how do you test that? This is right here, and it's right in front of your face, and it's pretty obvious what's happening. That's acceleration. The white is separated from the black, which is fission. It came back together, it's fusion. This is high luminosity, and that's what CERN calls it, high luminosity. And this is it. And I know CERN pretty well. I went to the University of Geneva for particle physics, and I told them about this. And they weren't using CMOS at that time. And I said, I can see these particles. And they said, no, that would be impossible. And we went through that for a while until they agreed, yes, because we are only using light. We're only using particles this big. And CMOS is made to pick up these. If you hit them with something like this, which they do that all the time, it's going to explode the CMOS. So that was the difference. Now they shut down and actually incorporated CMOS at CERN to be able to see the things the way we're seeing them. But we're started with light, so we don't have to dig through the debris. That's the key. You know, I got a series of a couple of things. You're talking about dark matter. Is it evolving? Well, what is that supposed to mean? So this is the universe's biggest mystery. Well, maybe. Enough of that. This is what they're seeing, CERN particle photos. They're showing this, but what happens with them? They're taking things like this and smashing them together, and they don't realize this has 1,839 dipoles, and they just go flying. Some of them go in chunks like this. Well, here, let me show you what CERN's description is here. This is how they show it. They're showing protons and neutrons coming together head on, and then everything goes. But they don't realize they're hitting these, and everything of these is going everywhere. So you're going to get some little bitty ones, you're going to get some chunks, you're going to get all kinds of different things, and they can see the exact same things we see, but they see a bunch of other stuff too. There's just nothing but debris. I mean, it's just debris. It's just balls of debris. And then they dig through it, and these are the kind of things they're using to create these kind of masses of debris that they're not, well, anyway, we're seeing light. We're seeing the particles they want to see. Because when they break this up, all they're doing is breaking it up to get to these. Okay, I got torn away for a moment, but I believe we were at the point of showing you that the CERN particles and Fermilab, because they're using these gigantic particles to start with, they're just getting a bunch of stuff. Very hard to dig through, very, very difficult. We started with these two particles together. They call that a Dirac neutrino. This is actually not matter. That one there is the electricity. That's what electricity is made of, has no mass to speak of. That is where the matter resides. That's where the mass is. And it's always one size fits all. Now that's the Dirac in its perfectly formed. A Majorna is the same thing, only it's in the transitional phase of becoming a photon, and I can show you that as well. Okay, this is from CMOS. The photography you get from CMOS is unbelievable, and it's the light spectrum that we're looking at. We're not looking at huge protons. These particles are photons. These are the tiny, tiny particles, and they're made out of the electron neutrino, the white one, and the muon neutrino, the black one. The black one never changes size. Now, remember I talked about the Majorna, or neutrinos, and here's one right here. These are Majorna. They're coming in and they're laying flat like this. They never do change other than flat or straight up and down, and they always stay in this orientation here, up spin or down spin. So these are the Majorna ones. They're not really fully formed. The only reason that these are formed perfectly is because they're going to smack right into the Venturi here. But the other ones form similar, well, they form energy states. You see this? White, black, white, black. Well, we got white, black, but these are, it's just different. Let's go with that. I can't explain it any better than that. So that's your two states of neutrinos. Your Diracs are the perfect ones, which we saw in the photons, and the Majornas are the non-perfect ones. Now, so that was the red. That was red. Now, let's talk about green. Same particle. Identical same particle, no difference whatsoever, only it's going much faster. And this one here, the white particle is charging up. You see it up here, it's getting charged and it's going to flip. And they just spin like that. They call it the muon wobble. Now this is blue, much too fast to really work with. It's coming through here, slowing down. And here it is here. So we can see light slows down. That's not a problem. And they know that anyway. So that's not a big revelation. However, this one is. We can speed light up. That's light speeding up. It's light speeding up. And space is not a vacuum. I mean, it's just so unvacuum. It's amazing. This is space. I'm working with a guy right now, Mason, who has, this is from, he's doing some really exotic stuff. He's got a Newtonian telescope with some special features and this and that, and filtration removed and so forth, where you can see everything. He's using some kind of method called stacked layering or something like that. I don't want to pretend I know what I'm talking about, because I don't. But I can see what he's seeing, and I can see the dipole nature of everything. But these are in clusters. These are not ball to ball, and I think I explained that already. I mean, look at it, they're right next to each other, so the dark part can move away from the white part. And this is how it all started. Dylan from New Zealand, Dylan Carpenter, sent me these. And he said, "What do you think?" And I said, "Wow." This has got to be 4 or 5, probably 5 years ago. But you can see all these fields in space. Space is not empty. It's just an absolute insanity to think light won't slow down coming through this. They have to break through each one of these fields. These things could be very, very close. There's some dense stuff here to break through. And they say light never slows down. Well, that is just not true. And it can speed up, it can slow down, it can do all those things. And it's not being stretched. They're saying it's being light. Well, they say that we know the galaxy's expanding because we've got a particle here that's coming from the expanding universe, which is pulling it, stretching it, so it turns more into the red spectrum. You see, it was going fast when it first started, but it's moving real fast this way, so it stretches here. That's not correct. It's just slowing down. It's coming through. It's just boom, 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 boom. And eventually it becomes the cosmic microwave background, which is all the particles you see right here just laying around in space. That's where these particles are. And that's where dark matter is. And dark matter is part of matter. It's part of light, and light is part of everything. You take light, I call it atomic vapor. That's light. These are the two particles, the dipole. This is atomic vapor. All right, and they come, the smallest semi-stable unit is the black and the white, which is a dipole electron. Then when you get the two back to back, it makes a photon a little more stable. And then after that, they're not stable at all until you hit 1839. And then they become a proton. That's dipole electron flood theory. It works fabulously. There's virtually nothing I can't explain, and I will talk to any physicist in the world about it. All right, you saw that. I say this is from Fermi law. I mean, I'm going to prove it right now. These are the two particles. We had the same two particles in light, using light. They saw these, but they can't explain them. And it always had the glowy edge around it because you can't see it until it obscures light because it's dark matter. It doesn't emit, it doesn't absorb, and it doesn't reflect. You just can't see it. Here's their article right here. That's where I took the picture from. The black one never changes size. You can magnify it and see it bigger and smaller, but it can't go like that by itself. This one has no mass. That has all the mass, and it says all that same stuff I'm talking about right here. And then the other one they did it, this is 2013. All right, February 2013. And it talks about this being a point particle, and it can get bigger, it can get smaller, and it has no mass to speak of, but it has a field. And I agree with that. I can't explain how it has so little mass. Because I think I told you, a 1,000-pound battery, when you charge it fully charged, it only gains approximately 45 thousandths of a gram. I mean, you can't even measure that. It's just unmeasurable. So I agree with what they're saying here. And I contacted them about it. I said, I found these particles. So I don't know, that didn't work out too well. Also, Don Lincoln showed this. Empty space isn't empty. It's like this. It's like the quantum foam on the head of a root beer, he says. It's just saturated. It's just saturated with particles. I mean, and you can see that. I mean, even anybody looking into space can see that. And when you see something like this, with all those fields, and the one that Dylan did over here, this one, you don't plow through that stuff just like it isn't there. That is all material substance, even though it doesn't look like material to some people. It should, because it is. And look at this stuff that Mason's doing. Yikes. But see, another major dipole. I think this was Saturn. I'm not sure. We haven't really communicated that much, but boy, I'll tell you, he's got some kind of stuff going on, man. Oof. Look at this. This is the moon. Now, what he's doing here, well, I'm not going to talk because I don't know. But I can tell you one thing. Everything seems to have a dipole nature to it. See how this is darker and this is lighter? Is this just because maybe the sun's hitting here? See, it's darker over here and lighter over here. These are kind of things require a little looking into, so to speak. Now, when we collided ours, nothing but photons. Now, when they hit here, they just sprayed. Now, this is what's called an electron shower. It magnifies the amount of electrons that are being pushed by, I don't know, thousands, tens of thousands. And this is an electron shower. And the energy level here is off the charts. And there's no reason we shouldn't be able to harvest that white right there and send it right down through some form of a diode, photodiode type of thing, into a power grid, or into, you could have it handheld. I've shown this many times, and I don't see any reason that wouldn't work. Now, again, this is what they see at Fermilab. I showed you the articles. It's not nothing I'm making up. And the only way you can see the black is when it's sitting on top of energy that's trying to get to you, and it blocks it out, because it doesn't absorb, it doesn't emit, it doesn't reflect. All it can do to be seen is to block. And that's what it's doing. It's blocking that red from coming at us and hitting us. All right, I think I've made a pretty good case for claiming that this is dark matter. And it's matter. All right, this has no mass. When you see the atomic bomb blast go off in very, very slow motion, the white goes out first because it's surrounding the black core. All right? The whites go out like that, and the house just vaporizes, and then the black comes behind it, and pow, out goes the house, smashes it to bits. The only thing that can really push something is the black. The only thing that can really burn anything is the white or the green or the red or the blue or whatever color it is. This has all the energy, that has all the mass. So this dark matter is mass when it's is energy. It's energy. It's mass, it's push. So this always rides with that, though. They used to call it a boson. I don't know where that name went to, but it used to be a boson, carrier boson. With the black always carried the white with it. It was a carrier boson. Yeah, here's right here. Bosons are the smallest bits and particles, the gluons, the Higgs, the photons, all of which I've shown. Then they get hadrons and fermions, and they overlap, and they do this and they do that, and they have all kind of flavors and this and that. These are the smallest particles. Gluon, Higgs, and the photons. See, here it is right here. Accelerated, separated, and glued back together. The gluons have become unglued. And this is where the electron neutrinos come, all by themselves. This is coming out of the Venturi. And then they hit, it's got to be a field of black particles. They got to be dark particles, because every one of these appears to me is the product of a splay of electron showers coming out and hitting. This one here is particularly, seems to me to be showing what's going on. This is a splash of the white particles hitting like a wall of blackness. It seems like that's what's going on. Look at it. It's pushing all of these fields as they join back together. They're called Higgs fields. Now we'll look at this one really carefully. Let me focus in on that one. You see that one coming out of there? Straight up. And then it hits the edge. Up here you can see the black and the white, black and the white. And then it just turns into this circle. It doesn't keep going. All right, you see it cut through here, straight through all these other ones. And then it found a particle to match with and created the field. All I can see is they're looking for a black particle to hook back up with. Instantly. I mean, this is instantly right after the Venturi. Now, this is kind of interesting because these are all red. Whoops, hold on. All right, these are all red from a red laser. Well, these jumped up a little bit on the spectrum up into a pretty excited area. And that's because they're pushing each other really hard together, it looks like right here. Anytime you see extreme amounts of glow, it means there's this extreme amount of energy. And it looks to me like it's pushing more fields and crushing that one, turning it sideways. And they're not supposed to be in certain orientations. They're supposed to be polarized towards the Earth. Even the green, you can see. You see this green? it's going this way. But it's still standing straight up. The Earth is straight down. All right, so you'd think it would, if it was spinning, it would be spinning this way, but no, it's spinning this way and travel in that direction. And the same thing with the red, even the Majorna ones. You see, they're flat as a pancake, and they're straight up and down as a straight up and down. And these are straight up and down as they can be. Now, we can make them turn and spin like this by pushing red and green together at the same time. We can make the red start spinning like a barrel. All right, this is red and green at the same time through the same venturi. And the fields are interfering with each other's fields. And this is the only time you're going to see them turning like this. It's because the green is going so fast, its field hits the other slowly spinning field and flips it this way. Normally it would always spin that way, and this one is. You see how the green is straight up and down, straight up and down? Well, it's just pushing the red out of the way. So the red does this and just stops. The green concusses out here again, because that's where it normally would have concussed, but it had to push these things out of the way, and then a lot of it still had full potential of energy and reconcussed way out there. You see, this is kind of funny, actually. As CERN began a significant upgrade to CMOS technology for its particle detectors in the 2010s. Well, what 2010s when? I was talking to them in 2015. They said it would never work. It says, with development intensifying for the high luminosity, which is what I'm showing you, Large Hadron Collider upgrades still ongoing. They just started to upgrade a few years ago. I think 2019, 2018, they started to upgrade it. They say the 2010s, so they can say that they were doing this before I introduced them to CMOS technology. I introduced University of Geneva and CERN and Fermilab, and all of them. Every one of them I tried to contact, and I said, you can use CMOS. Well, they said, no, it's impossible, but then I went to University of Geneva as a student so I could interact, and that worked. And that got their attention, and then they went ahead and did this. Ongoing future upgrades, continuing to develop and implement CMOS technology. It works fabulously. Yeah, you see right here, 2019. CERN Large Hadron Collider will undergo a major upgrade to increase its instantaneous luminosity. It says this work focuses on the design and integration of novel radiation-hard monolithic CMOS pixel sensors for new trackers. That's the problem. When they smash and hit these things and they hit those detectors, they destroy them. Now, I'm going to tell you something else. The people that are working there are being injured and they don't realize it. And I can tell you what's happening to them and how they can figure out how to fix them, because they're being injured because their bacteria is being killed in their body because it's being hit by radiation. And they can test these people for what bacteria they have in their fecal swabs to see what bacteria is being killed. And the more bacteria you kill with the radiation, the more enzymes you lose. And if you take acute radiation sickness, now that means you get blasted with an accident and boom, a whole batch of radiation comes. And you are irradiated. Well, guess what happens? You don't get sick immediately. A couple of hours later, you start throwing up and you have diarrhea. Stomach starts gurgling and belching and acid reflux and vomiting, and you have destroyed your bacteria in your digestive system. And that's how fast the digestive system works. It only takes a couple of hours for acute radiation syndrome. Depends how much you got whacked with. But those people should be tested for bacteria, and they should be taking probiotics. That's my opinion. And they should be taking soil-based probiotics. All right, they have to wear badges, and they're going to find out how many millisieverts of radiation they get a year. They say a limit of 3, and that's pretty high. Actually, they're saying a regulatory limit is 6, but 3 is pretty high. I think they say for the general population, 1 millisievert per year is about as maximum as you want to get to. And beyond that, what happens is you damage your bacteria, and the bacteria don't create the enzymes. And then you get sick. It can't be any more obvious than this. Acute radiation syndrome. It's a serious condition, occurs when a person is exposed to a high dose of ionizing radiation. That means the ones that rip the electrons and can really cause damage. A high amount of radiation over a short period, typically caused by accidents or intentional exposure to nuclear or radiological materials. Now, symptoms, they vary depending upon the dose of radiation received and the time since exposure. So they're talking about the time since you were exposed. The early symptoms, now this is within hours if you really get whacked, and in days if you're not quite as whacked. The early hours may include nausea, throwing up, vomiting, diarrhea, fatigue, fever, skin redness and swelling. This has killed the bacteria that's roaming your body, which creates the enzymes, and you need those enzymes 24/7. When you kill your bacteria, if you kill enough of it, you're done. And these are the symptoms that last days to weeks. Bone marrow failure, bleeding and bruising, infections, gastrointestinal damage, neurological problems, seizures, coma. There is no cure for ARS. Well, let me tell you something. If they looked and see what the bacteria in your gut is before and after one of these exposures, I can almost 100% guarantee you're going to see a massive change in what bacteria is still alive in the body after exposure. And that's why all of this stuff, the treatment options include antibiotics. No, that makes it worse. Antibiotics, you need good biotics in your body. Antibiotics is to kill invasion of little creatures. Absolutely crazy. Stem cell transplant, yes. And I'll tell you what else will work is a fecal matter transplant, which is a microbiome transplant where you put new bacteria in the guy's body. There's a new way of handling disease if it could be accepted by the professionals, and that's the microbiome, which creates every single bit of chemistry in your body that does anything whatsoever to keep you alive. 100% of your living biological ability to live is created by enzymes. They work fast enough to facilitate life. Nothing else does. You need the enzymes, and they only come from bacteria. You kill your bacteria, and you won't have the enzymes. Bacteria live in colonies. If you destroy the colony, it's not coming back. If you damage the colony, hopefully it will have the wherewithal to come back and re-protect you. They're talking about long-term health problems. If it never comes back strong enough, you're still going to be in trouble over your whole life. And the same thing with vaccinations. When a kid has absolutely no ability to fight back against the live viruses they put into you, and they figure your body's going to have enough wherewithal to fight back and say, we'll kill that stuff. There's hardly anything there. Don't worry about it. Go kill it. And your body does, 99% of the time, or whatever the percentage. But vaccines work when you have enough bacteria in your body to fight back. If you don't have any at all, that bacteria comes in and says, hey, I can live over there. There's nobody living there. They left that whole place empty. I said, well, let's go over there. And then now you got trouble. Something who lived there that's not supposed to be there, and it just never leaves until you can come back and displace it with the correct occupant, which is the correct bacteria, creating the correct enzyme, creating the correct chemistry, building blocks, energy, everything, all done because of the bacteria. 100%. All right, I think I'm going to leave it at that. But what I have just shown you is the standard model is built on absolutely nothing. Physics is built on complete wrongness. There was no big bang, possibly. Maybe there was. But they're saying we figured out soups and quarks and gluons, and then this and protons, and then nuclei, and then this, and then 4.5 billion years ago the Earth was here. Well, no. And they're saying it's just completely obvious that the universe is expanding. I say, no, it's not. The only way it's obvious is if you believe light will not accelerate or slow down, and that is just completely wrong. That is completely wrong, and I have shown it. You can accelerate light. That's not allowed. When they say it's almost going the speed of light, like there's nothing you can go faster, obviously that's faster than it was going before. And they talk about being in the median it's in. It can slow down. They know that. Yes, I agree with that. But it's not supposed to speed up. And that they can't get their heads around that. And all of this stuff, I don't see any expansion there. I see just a blob of stuff out there. And light coming through that is going to slow down. There's absolutely no question about that. So it's built on either a pack of just wrongness, or at this point they're lies. They know that. They know that this is not going to, that light is not going to slow down through it. Of course it's going to slow down. It's absolutely amazing what has been forced upon us to believe. It just isn't right. And anybody in their right mind knows it isn't right. Yet we are saddled with it. So as far as I'm concerned, we can figure out all of this stuff. Everything started birth of the universe. No idea about that. None. Zero. And these are the particles. This is as close as anybody's gotten to it, is MIT. But they're saying they're all kind of crazy things going on. No, this is what's going on right here. This is what protons are made of. The black, this is right to the center, and the white goes around. Even the Russians found this in space. Did I show you this? I don't even think I did. This was 2015 too. I got a hold of them best I could. I never got anything back. This is charged particles in a vacuum chamber pushing all the dark matter to the center and surrounding it with the white particles. That's dark energy. You can't even see behind there. You should see something behind it. You can't. It doesn't absorb, it doesn't reflect, and it doesn't emit. That is black, dark energy right in the middle of these little white particles. And they freaked out. They said during the experiment we contacted the Earth guys who couldn't believe it either. They went freaking crazy. And I'm going to do a video about that because that was 2015. I understand a lot more now than I did then about the interaction of when they were looking at particles and they're showing them swirling and doing all the things. And years ago, I didn't have the handle I do now on that. And I realized they were pumping energy into it to look at it with lights. And they're just sending nothing more than little particles in. They didn't realize it. So they were exciting everything and making everything go this way and that way and all kinds of crazy stuff. And they were freaking out about that too. It's just amazing what they did 10 years ago. So as far as I'm concerned, that's a black hole. And this is dark matter. And dark matter in a collection makes a black hole. That's all I can tell you. All right, thank you. I think I've made my case. And if nobody will contest this, and I have no experts making statements that will step forward to discuss this, then I win. And what I have said is correct. And I now own physics. Dipole electron flood theory supersedes the standard model, and it works. All right, with the standard model, they can't explain gravity. They can't. The dark matter is the biggest mystery in history. Every day, I get more and more about this history mystery. Huge mystery, biggest mystery in history. Scientists just solved a black hole mystery, 100 years in the making. That was one of them. This is the one. Whoops.
Эксперименты, проводимые на орбите,
This was the one. Unbelievable. And they're showing all kinds of... Anyway, I'm going to go through that at some later date. But here's this... I went through all this. I don't see any reason to keep going through it over and over and over. So, that's what I have presented. And again, I win unless somebody will step forward and contest this. Dipole electron flood theory is now the standard model. The standard model that was accepted, but just couldn't figure out gravity. I mean, come on. The dark parts suck the white parts in. We're standing on dark matter. The white part has no mass. Has no mass. You step on a white part, you go right through it. You step on a dark part, you're standing on mass. The Earth itself is basically very, very dense with dark matter. That's why the electricity goes right to ground. Static, lightning, all that is the white part. Static and lightning and electricity is just the white part. And it's this we know for sure, because when you charge a car up with electricity, it does not gain any weight. For a 1,000-pound battery, it gains it gains 45 thousandths of a gram to fill up a 1,000-pound battery and then drive 500 miles. It has no weight. All right, I'm going to leave it at that. Thank you all. Love you all. We should be able to do something with this if it was looked into. I think we could get free energy, but it needs to be looked into.